Okay, finally ready. We had this, or good morning, huomenta for everyone. We had this word in Finnish, so this is called mouse in English, and in Finnish it is hiiri. Mouse is hiiri. Also the animal mouse in Finnish is hiiri. I couldn't find anywhere my lesson notes from yesterday. I probably have forgotten those when I scanned them to the Moodle, so I actually can't exactly remember what we did yesterday, but let's continue handling with these oblique triangles and cosine rule and sine rule. And let's take another example. And in this example, we will solve all the parts of the triangle, not only some side or some angle. So let's take this kind of example. I don't know if this is the third one. Yes. So we know A28, not units again, and I have to change those stupid starting values there. And then alpha 25 degrees and beta 31 degrees.
Sorry, yesterday I noticed something in the examples that we did yesterday.
Ah, okay.
We use A, B, and C.
Yes.
As your sides of the triangle. So you always notice that C, side C, is always confusing with the constant C.
Yes, in this second order equation, yes, that is probably. Unfortunately, I don't have those.
Do you want to see?
Yes, see that C.
Which one? I don't know which one, but it starts from here or the next page. You can
Yeah. So these are the lesson notes from yesterday, I guess. And what was it was this example.
Yeah.
C constant and C the side of the triangle, the longest side of the whole.
Yeah.
The longest side.
So in this formula, which was taken from the formula book, the C was the constant which had no x's after that. So it is simple number. So in this case, we had this kind of equation, and our C is this number here. So this is this constant value there. Unfortunately, we had the unknown in this formula. We named that also C because it was the
Exactly. Substituting directly.
Yeah. So here the only place where you have to put that constant is here in that equation. Here in the last number or last value in the inside the square root. Yeah. And this was example. Actually, yesterday's examples were both quite stupid because we didn't get any answer from that, but it was because our triangle was not, it didn't exist at all because it was impossible to draw that kind of a triangle in which all these holds. We draw some kind of picture there in the beginning, but we got the answer with the help of sine rule that the angle alpha was undefined there, and also using cosine rule we got the result that the length of the side C was also undefined. It was not able to calculate. Yeah, thank you. Okay, and in this example we have to find out B, C, and gamma. They are all unknown, and also area. Let's take that also. Area of that triangle. Now we have maybe more possibilities to start the calculation. What would you do first?
Well, we draw the triangle first.
Sorry.
Try to draw it.
Yeah, draw. Yeah. Oh, yes, this is possible to draw.
Yes.
Yes. Maybe it's easier to. By the way, sorry, not it was not yesterday. Yes, I forget what I was trying to say. I had a thought that we didn't remember to check from the picture. Of course, always if you draw the triangle first, so after you get the result, it is important to check from the picture that you got almost exactly the same value as the picture shows. But of course, in that case, we didn't have any picture because it was impossible to draw that triangle. But now we are going to draw that triangle, and let's take A first. So I will turn. There is only one side to draw, and I will use that kind of scale that when I have this ruler here and 28 is the value of A, I will multiply that by 2, so I get 56. So it is more bigger one, the picture. I'll take 56, the length of this in this picture, but I of course I write it as 28. And then we have the alpha angle. It's opposite of this A, so it must be somewhere here, but we don't know the place. So let's draw first this beta. So there will be 31 degrees somewhere here. So this side will go somewhere like this. We don't know the length of it yet. And alpha is somewhere here, and alpha triangle should be 25 degrees. How can we find that kind of degree?
On that line, that's line. You put it on that line.
Yes.
Yes.
Let's take like this, and we should. This is too big of a ruler. But I would say that 28 degrees. 25 degrees. It is somewhere here. So let's try to find that from this. I will take another. Do I have any? Yes, this is more helpful to use is also 28 degrees, was it 25 degrees? So it would be somewhere, not very easy to draw, but I guess it is somewhere here, probably. No, it's quite well there, so it would be somewhere here. This is a little too big, this how do you call this? Compass. No, it wasn't compass, it was, what is the name in English for this?
Set square. Set square.
Astellevy in Finnish, but I forgot the name of it. Yeah. I think I yesterday remembered that, but now I forgot it.
Set square.
This is set square.
Set square.
Okay, I've never heard that name, but okay. But here we get the alpha, it is equals 25, and of course we didn't write, or I didn't write this beta.
The stupid name is like set square, but it's fine.
Yes, I know. For example, carpenters in building sites, they use this word square from the triangle. Yeah. I don't actually know why, but it is the quite.
So what was it in Finnish?
Astellevy. But this is Astellevy. This aste is degree, and this is like a plate.
Yeah, like
Degree plate.
Yeah.
But it is also called geokolmio. Kolmio is triangle, and geo comes from geometry. Geometria in Finnish. So it is this kind of. Okay. Now we have this picture here. And what could be first to calculate?
About the sides, yes.
Yes, sides is okay, but maybe the angle is the most easy one. There are two angles we know, and we need to find, because when we know all three angles, it gives sometimes more possibilities to continue. Yeah. So this is this. I usually write gamma as like this, but I don't think that is correct one. Actually, the gamma is written like in this picture. You see it there, and yeah, as a handwritten. Sometimes when you try to write that gamma letter, it seems like a Y letter, or if there is some kind of circle in the bottom of the what is the alpha letter? Yes, but if you make that too big, so you may misunderstand and think that it is the alpha letter. This would seem a little bit same. So I think my teacher learned or taught me that if you put this kind of extra curve there, so you don't mix it with alpha or Y letter. But I don't know how it actually should be written when you are writing that by handwriting. writing that letter. So how do you calculate this gamma?
5 plus 31 minus 180.
You should have 31 and 25.
Yeah,
Then subtract 180.
yeah, the same as you said. So we could do it so that we subtract 31 and 25. Because all the angles in angles in all triangles add to 180 degrees. How do you say this number in Finnish? 180. Yeah. And that becomes 56, 144, 4 is it? Mathematics teacher uses his calculator so that you don't see it. And yes, that was good because I I calculated it first wrong. Yeah, so it was like this. Yeah, 56 away from 180, 124 degrees. And now we know all the angles, and B or C, which would you like to solve? We could use sine, yes. This sine rule is, I think it is the most easy way to to solve sides of the triangle if you know all the angles. So let's use sine rule. And then let's start with that B, solving solving B. So B is here, the length of this side, and C must be here, opposite of gamma. So B divided by sine B equals A divided by sine alpha. And we know all the values of the letters in that equation, all but B. B is unknown. And this sine rule always you solve, or you can solve it always by cross multiplication. So let's do that. We get B times sine alpha equals A times sine beta. And then we get this unknown with the help of division. B should be solved, so we divide it by sine alpha. Sine rule is quite easy to solve because it goes always with the same way. There are no exceptions. Sine alpha. And then we put the starting values which was given in the problem. A, alpha, and B, beta. let's put brackets there so it's easier to see that angle there. Is it better or worse? Which is better? There is a small lamp there, but I'm not sure.
It's quite okay for this.
Yeah. And then we get the calculator. 28 times sine 31 divided by sine 25. 34. 34,12314. And after this, usually we do the rounding. We don't give the answer in the exact. We don't give the exact value of the answer, but we round it. For example, to let's say we don't have any. Well, actually, the starting values were all given with 2 numbers. So actually, we should round this with 2 numbers. So it would be like this, but that is quite boring way. So let's round it to 2 decimal places. But before we do that, let's check that if we got that correct. My picture was drawn so that these sides are multiplied by 2. So this side, which was 28, I draw it with the length of 56, or maybe it is not exactly correct, but about 56. So this side here, B, in my picture, it is about 69 millimeters. So if I divide that by 2, I get 34.5. So it is quite near the value we get. So probably we made that okay. And let's round that, for example, in 2 decimal places. So it would be 34,12 or 34,12. Well, this was only my choice. In this problem, there was no actually need to round to 2 decimal places, but I just made that kind of choice. And then C. I think the same holds. Maybe C is also okay to solve with the help of sine rule. There are also other choices because we now know every other part of the triangle, but not this C. So, for example, we could also use cosine rule, but there is this problem that if we use cosine rule, we have to solve this C. We need to use the value of B, and the value of B is this value here. So that makes that we have to use very exact or accurate value of B, because this rounded value, it gets rounding errors to our calculations. And this gamma angle here, even though it is calculated from the starting values, it is exactly this number. So there are no rounding errors in this value. So I guess it is the better way to use the sine rule for solving C.
Well, the final answer there, that 34.
Yeah.
In this case now, we want to use the cosine. So you can round it up to, let's say, 34, since the original numbers are all in whole numbers.
Yeah. Yes, but if you use if they are all given, well, actually the rule is not that they are all given in whole numbers, but they are all given in with two significant numbers. Yeah. So actually I should round this with like this, also two numbers. But if I use this value of b to further calculations, I should use more exact values, because then these rounding errors, they come all, yeah, bigger all the time if you use rounded values. Yeah. Many calculators nowadays, you don't have to have this kind of expensive calculator, but also many cheaper ones have the possibility to put these numbers you get to some kind of memory place, or you can pick them from earlier calculations. So there is nowadays necessary the problem to use rounded values, because you many times can get the exact ones from the calculator. You don't have to write all the numbers or all the figures of the number to the calculator.
There are also apps. I know you can't use phone on exam, but during the lesson I just look for some scientific calculator apps.
Yeah. Did you find that?
Yeah, I found scientific calculator. But no.
Yeah. Mostly this like this first, but if you turn it in this way, you get more scientific one.
Nice. But we at school never had this, like we didn't even learn how to use those scientific calculators.
Oh, is that so? Yeah. So we have the same method when solving the C. So as here now here we solve the B, and now we want to solve the C. So it is the exact same, but we change B to C and beta to gamma. So it is C divided by sine gamma, A divided by sine alpha. And the same holds here. We cross multiply. C is the unknown, so it is better to start cross multiplication with this C here. So we get C times sine alpha equals A times sine gamma, and then again dividing. So actually there's exactly the same formula here. The only difference is that this beta is changed to gamma. This A and sine alpha are exactly the same. So for example, in this calculator I may copy this one here and only change the number inside the sign, the first sign there. So it will be this, and then I get the answer. $54,5 0,9267. If I say it in as in written Finnish, I say it 54,9267. But if I say it in my dialect, I say it 54,9267. More quicker or short words.
I think also another option from where we start the triangle.
Yeah.
So because now mathematically we are getting the formulas, we are getting the unknowns.
Yeah.
So now it means when we are drawing the triangle, we don't have to be accurate. We can just sketch it.
Yeah.
And then when we are ready, then we can use our values to draw it properly.
That is yes. This is yeah. And of course, when we have these exact values, we could draw that triangle very accurately. Yes, and then it is quite easy to see that does all these values fit in that triangle. That is okay. Yeah. But right now we got this, and if I check from my drawing here, and it is the length of side C, 55, so, about 55. So if I multiply that by 2, it gives 110. So I should get 11 millimeters here, and 11 centimeters here. So it is exactly. I don't have to lie to you that I see that it is exactly 110 millimeters. So probably we get this right. And if we round this again to 2 decimal places, so it will be 54.93. So this goes up because there is 6 after this 2 there. And this is our answer. How about the area of this triangle? We have solved all these now, but this area, how do we calculate the area of this triangle?
We divide the triangle into 2, right angle triangle. So we can use that one.
Huh? What?
We divide the triangle into 2.
So you mean, for example, like here?
Yes.
Yeah.
Fine.
Then we use that. Then we find the depth.
The height of that. Yeah. It is possible to use.
We use half the base times the height.
Yeah.
Triangle A, half the base times height.
Yeah. Yeah. Do you have any other options?
Or you use the formula method.
There is, yes.
The formula.
If
I don't remember that.
Yeah. Actually, this formula I'm showing to you, it uses the method you said that you make the two right angles from these triangles and calculate here. So if we want to solve the height of this triangle, so I mean this length of this length of this part here, how could you calculate it from this triangle?
You can use beta or alpha.
Yeah. And if you know that this is 28 and this angle is 31, how do you calculate this?
We can use opposite over ISC. Opposite over.
This should be right angle.
Yeah.
It's a right angle.
This is right angle.
So we can again the same thing. We can subtract from 108. 31. it's 1 and 90 degrees.
Yes, you get the angle, but if you want to solve the length of this side.
Okay. So we can use
opposite over either side.
sin B. No. Yeah, sinus B.
Yes, it is sinus, yeah. If you know the value of hypotenuse and you know this angle and you want to find out this side here, so it will be sinus because this is opposite and this is hypotenuse. So you use sine, and if you know hypotenuse, you only have to multiply this hypotenuse with the sine of this angle. And if we turn to this triangle here, so this is also right angle triangle, and we now know the value of beta here. Oh, sorry, B here. We calculated it was about, what was it, 34 about. And now we also know the value of this angle, so we could also calculate the height of this triangle. And what would it be sine or cosine or
Sine again.
Sine again, yeah. Actually, this method is the way to how do you say it, to prove the sine rule, because we have any angle we just take, and we every time can make two right angles inside of it, and we get the height of this triangle either from this triangle or from this triangle, and both uses sine.
Yes.
And that is where you get some kind of, or exactly like this kind of formula, because this height is the same in both triangles here.
Yeah, it's right opposite two of them.
Yeah,
so
yeah.
That's why you have to use the two methods.
Yeah, but we actually don't, when we have this any triangle or oblique triangle, we also have a ready rule for that, which uses the
Formula method.
yeah.
I saw the formula method, but I don't remember it.
Here it
It
is.
says A equals
Yes,
something over something squares.
here is one version of it. I think in my my material in Moodle, I probably had that formula. Try to find that. This is always the problem. All the world gets my password. It was a mistake. Yeah. Moodle.
Yes. Any of this A equals A times B sine of Y over 2, or A times C sine of B over 2.
Yeah.
And C, B times C sine of alpha over 2.
I seem to love my photos because everywhere. Yeah. But it was a nice day in our garden, and I took that picture of me.
So you grew up in Sweden?
Actually, I was 5 years old when we moved back to Finland. My parents lived there as immigrants about 10 years, and I was born there.
Do you speak Swedish?
Actually, I didn't speak. Maybe I understood some Swedish when I was a child, but I forgot that everything. And my Swedish knowledge is from school, because in Finland we all have to study Swedish. But I love Sweden, and I have a how do you say? It is flag of the that area where I was born in Sweden. I have in my garden. Yeah.
That's not many Finns say that about Sweden.
Yes. Not so many Finns love that.
But it's really beautiful. Sweden is beautiful also.
Yes, I like. I was born in the southern part of Sweden, and I'd like to visit there. It is many years that I visit there, and maybe next summer. I hope. So here in this study material, I have this PDF here, and there I think I wrote the formulas there.
Sometimes doesn't open.
Yes, there's some slowness right now. Now it's trying to open them out. In formula books, there unfortunately many times there is written only one version of that formula. But you can remember from this formula here that there is always these three letters. If you have B and C here, so inside the sign you have to use the third letter, so it must be A, or in Greek form alpha. If you have A and B here, so there has to be C or gamma. If you have A and C, so here you have to here you have to be beta or B. Well, somehow it doesn't open now. Let's forget that. But also we can try to remember the rule of like this, that of course we have here a picture of some kind of triangle. If we look at this formula here, there is B and C and alpha, so here is B and here is C, and between them is alpha. So that holds every time. So if you want to use these sides here, A and B, in between them there is gamma. So use A, B and gamma. And if you use these sides of the triangle, between them there is beta. This is somehow written in two parts, but this is beta. And A, C, and between them is beta. So you put those in this formula. So in this case, it is possible to take any sides. For example, we may take, for example, this angle here. We have alpha and we have B and C between that alpha, so we get the area with that method. So we could write it BC times sine alpha divided by 2. B times C times sine alpha divided by 2. Or A and B sine gamma divided by 2. Or what is the third version? It was here. AC, yes. AC, yeah, sinus beta or sine B divided by 2. This dividing by 2 you also can write as like here, multiplying by half, 1/2. Here actually is the usual formula for triangle, area of triangle, half of the base times the height and divided by 2, or base times, so half times c times, sorry, 1/2 times base times height.
Yes, and it has to be
Yes, here it is this lower index here, or indice here. It means that it is the height which is drawn to this base c. So if we have c here, the height of that is hc. So if we take the first version here, b was calculated and it was 34, and now I use a more exact value here. I'm not using the rounded one. And see, this actually was the worst choice of these because because we have to use these calculated values, and they are usually more nasty ones than the starting values. But of course we get the correct answer. Well, this alpha was given in the problem, so this is easy one. Let's put the letters the B and C and alpha. But for example, with the help of this calculator, it is easy to pick those exact values from the calculator. I have here this 34 and this 54 is here, and I only have to.
Yes. This formula method is easier than the other method.
Yeah. Yeah, that is correct. I mostly use this when I calculate the area of triangle. So I pick this, so now it is it has the blue color above it, and I pick that there, and then I put times or multiplication mark, and then I pick this 54 there, and then I get sine 25 divided by 2. Yeah. If these values or lengths have the unit of meter, so what would be the unit of the answer? Yeah, meter squared or square meter. By the way, square meter. Or this. What is it?
We have not used any what is it? We have not used any units.
No, we haven't. Yeah.
So now we are saying square meter.
Yeah.
So it should be just square.
Yeah. That is unit.
Yes.
Unit squared. Yeah.
So it could be centimeter square.
Yeah, that is correct. How do you say this in Finnish? What was this square? Neliö. Yeah, neliö, and meter is metri. Neliömetri. How about cubic meter? It means meter raised to the power of 3. Actually, it comes not in Finnish. I don't have to use as this kind of again my drawing skills, but I try to. What is this called in English? Cube. Yeah. And in Finnish it is kuutio. It actually comes because in Finnish kuusi means 6. It means that there are 6 sides of this particle. 1, 2, 3, 5. Like in dice.
Yes.
Yeah. You throw dice. There are 6 numbers there. 6 different
Why
numbers.
did you use like in English a cube? Why is it different? Because if it is a cube, the reason is that there are some sides that are equal, so they don't have to count them. They just count things that are different, like the length, right, and the height.
Yeah.
So it becomes cube, because those are the ones you are going to multiply together.
Yes. What is the name of that? This I'll have to. For example, this is in Finnish. This is the man or woman who has made this Kaavasto, he or she also had some problems with drawing skills because this doesn't seem to be a cube actually, but the sides are equal, so it is kuutio.
Yes.
And this is called suorakulmainen särmiö. Siis, yeah, and there are different measures of these. Yeah. Suorakulmainen is right angled. And särmiö is, but I don't remember the word in English. What is this?
Which one of them?
This.
Yes. A rectangular cube.
No, is it cube?
Yes.
Is it really?
Yeah, rectangular cube is there and a square cube. So in a square cube, all the sides are equal, and in a rectangular cube, where the sides are different.
Yeah, I have to check that, but I'm not sure. Yeah, okay. Särmiö. Actually, I don't know where this word comes, särmiö, because well, yes, we called these sides särmä, but in spoken language, I don't know if.
The other ones in English, the one that is in dasta, they are called diagonals.
Yes, diagonals. Yes. Let's take that. By the way, this was kuutiometri. For example, if I have a square here and I draw this here, which is many times we use D letter, and D is diameter in English, and in Finnish it is lävistäjä or halkaisija. Both are used, but maybe in this case lävistäjä. This lävistäjä word comes in Finnish lävistää. It's some kind of you cut something in pieces or is I don't know how to explain that, but it is something to do with when you use knife and put some parts, the piece of cake, you make lavish the cake. Well, actually not used in this case, but it comes from that.
So,
yeah.
The other one we are talking about, square and rectangular. It could also mean cuboid, depending on what you are drawing. Cuboid.
Cuboid, yeah. The word like the.
Yes, but then you have to show, when you say cuboid, then you have to show every area, like what you are representing. It's like a 4-dimensional.
Yeah. This is more universal. Concept.
Yeah. So this is your conclusion.
Let's have a little break here.
Yes.
I this stop this video.